Hi guys and welcome to Learn Extra Live. It's a Monday, that means it is maths and it is grade 10 and I'm Indiana, and as you can see I've got E.T. next to me. How are you?
They sound the same. Yeah, I'm all right. How are you?
No, I'm good. The two
Good, good.
eyes. That's
Yeah.
what we've been discussing. We're the two eyes today. And today we're going over statistics. So tell us a bit more about it, E.T.
All right. Today what I'll do is basically just try and give a broader picture. I won't tackle a lot of questions. I'll just give simple examples just to illustrate the concepts.
Okay, perfect.
Yes. Then this will continue into next week, and we'll do a lot of questions next week.
Okay, perfect. So take your spot at the board, and what I'll do is that I will chat to the learners and tell them what they need to know. And what you guys need to know is you need to go to facebook.com/learnextra and post your questions on the page, help each other out, and get chatting. You can also chat to us at Learn Extra on Twitter. And don't forget, every week, guys, every Monday and Tuesday, we do give away a Casio calculator and a labeler to those who post the best post on the page. Now, what that can mean is either you've helped somebody out, you've inspired somebody, you've posted a question, anything. Don't forget that this community is not only for us, guys, it is also for you. So without further ado, I'm going to pass you on to E.T. If there's anything you aren't understanding, please let us know on the page and we will help you out. So E.T., take it away.
Thank you, Indy. Greetings to our viewers out there. Please take out your pens and pencils. You may have to write down some few definitions, and I'm going to talk more about the concept today. And next week, just prepare questions, then we can talk. We can discuss questions next week. All right. Statistics, yes. Typical questions that you'll come across, or statistics is seeking to answer, will come from the political environment, from the social environment, from the economic environment, or from the environmental. You'll get environmental questions being answered by statistics, the subject of statistics. Right. Typical questions. Political questions would be typically, what is the general acceptance of a ruling party's outlined plan of action? Those kind of things. They may have to go and do a survey, to see what is the view of people. What is the acceptance of the plan? Social, economic, and technological typical questions could be, how widespread is poverty in the far-flung areas, in the rural? Who buys the newly launched technology and for what reason? Those kind of questions, which may feed into a market research and those kind of things. And environmental questions typically could be, what is the effect of industrialization in our atmospheric resources? Typically our oxygen in the air, are we busy displacing our oxygen that is so important for us to breathe each and every day? All right, so those are the typical questions, just to set the tone. And if I move on to the next page, let me define statistics in two ways. There are activities that that are being carried out when we talk about statistics. So let me define it based on activities. Activity-based definition is basically where it entails a collection, evaluation, and interpretation of data, which in the end will be presented as useful information for decision makers, right? In government or in the markets, like I said earlier on, when posing the questions. Then you can look at it differently and say, well, what is it trying to achieve, this subject? So I will call it a function-based definition of statistics. A function-based definition, basically, that's where you can say statistics serves to reduce doubt or uncertainties about the information that is being presented to you for your decision making. And alternatively, you could look at it backward and say, this thing is going to increase trust in the information that I have, so that when I make a decision, I'm sure I'm making the right decision. I said increase trust and reduce doubt. If I can just underline that, just to show you what is important. You can forget everything about that definition, but don't forget those two key points. under function-based definition. Under activity-based definition, like I said, do not forget these things. That's what is important there. There is collection of data, evaluation of data, and interpretation of data. So those are key for you to remember the definition of statistics. All right, if I move on, that's the definition of statistics. And now you can say, well, we said we're going to collect data, and what kind of data are we going to be collecting? Our data is going to be quantitative and qualitative. So when I say quantitative information or quantitative data, that's where you're talking about things that you can count, things that you can measure, like the length, the area, all those kind of things. So when we talk about counted data, you will come across a word called discrete. So just know that it's talking about, you counting the cows or the number of cars. You can't have a cow unless it's dead. All right. Qualitative data, that's where you're talking about colors, emotions, the moods, the opinions, the perceptions, etc. All right, so that's qualitative data. Sometimes people are interested in that. All right, and the methods of data collection and the sources of data. There, basically, you can do experiments to collect data. You can do surveys, and you can do, conduct interviews, and you can, send out a questionnaire which people, if it's well prepared, will answer the questions, and then you get a whole lot of information from which you can make decisions. Yeah, that would be current data basically, so that you are collecting. Yes, you can go to archives to find information. So that becomes historical data that is in the records in the archives. All right, historical data. So in the end, that collected data must always be a sample that is representative of the source population. So you look at the whole population, and you just have to, if you just don't have the time enough or the resources to go and count everyone or measure everything, you then take a sample. So that sample must be representative of the population. That is, it must bear similarity. It must bear similarity in terms of characteristics with the population which it is meant to represent. All right? If I move on to the next one, like I said, there is going to be a lot of writing. Pen and paper is important. Let's move on. Evaluation and analysis of data. Yes, your evaluation of data will involve you doing algebraic analysis and graphical analysis, the likes of standard deviation, those kind of things, the graphs that you draw, the distribution curves. So those are statistical analysis. That's what we will be doing in this subject. All right. Next is you then take interest in, yes, I've collected data. How do I measure the central tendency of data? Is there a central tendency of data? So there are a few statistics that we can measure there. Typically the mean, the median, and the mode, they're all talking about the central tendency of data. There I have underlined mean, median, and mode. For grade 10s, that's sufficient to at least talk about the central tendency. The mean of data, what exactly is it? It's basically an average in statistics. But let's define it in an alternative way, where we say it is a reference value associated with the data that you have collected. So you want some reference value where you can say I'm falling short or I'm going over. So it is such that the sum of the actual deviations of the data is 0. So what am I saying? If you had, I will use this space here. If you had data that is falling you know. All right. So if you look at it like that, so you've plotted all those points there. Now, that line that I've drawn there is going to be, let me represent it as X bar. Notice there the way we symbolize the mean of data. So you've got X bar and all the other values like X1, X2, X3. So these are the measurements that you have taken and they are bouncing around that middle value. So what will happen is if you take this middle value and multiply it by, if I can just extend this, if you can say n times that mean value, you are going to get exactly the sum of your measurements. So you can see that's just cross multiplying that. So if you look at the differences of all these, the deviations, how much they fall short from the mean, when you add those differences, some of them will be negative, some of them will be positive, and in the end, the sum of the actual deviations will give you 0. Okay. And alternatively, you could say the sum of the measurement is the same as the product of the mean and the number of measurements. That's actually what I represented there. Okay. Right. So I said the sum of the measurements, sigma here stands for the sum. Remember this sigma, it's very famous, you use it in many topics. Sigma is the Greek letter for the sum. I mean for S. So we use it for the sum. All right. So there I'm saying the product of the measurements, number of measurements, and the mean gives you the sum of the actual measurements. All right. If we can move on to the next page. We can take a simple example which you can easily work out at home there. We are saying here, find the mean value for the numbers 1, 2, 3, 4, 5. They are given that information, that data. And to find the mean of that data, like we said, you now have to add up your measurements, all right, and divide by the number of measurements that you've taken, all right? And as you can see, this is an easy one that I've picked. 4 and 1 gives me another 5 there, 2 and 3, another 5. So this is actually 15, 5 plus 5 plus 5. It's 15 divided by 5. That is equal to 3. Because 5 goes once, 5 goes 3 times there. All right? Then we say the mean of this data is 3. And if you look at the data itself, you can actually notice as well that 3 is lying right in the middle of data. And we said we are interested in the central tendency of data. So that's just one example that shows you that, yeah, indeed, going for for the sum of the measurements and dividing by the total does throw you right in the middle of the data. All right, so that was just one simple example there. And the mean, the next one is the median, another measure of central tendency. And I'm saying here, measure the central tendency of data, and I'm going to talk about the median and the quartiles. So you will see why I'm going to talk about the quartiles as well, because these are just other medians, depending on the positions that you are looking at in terms of the data. All right. A median is a reference value. Again, I'm talking about something that is a reference, and you're either on the left or the right, or above or below. So a median is a reference value in the middle of data when measurements are arranged in order from smallest to largest value. All right? For the given example above, the middle value for position, by position. Now, that's another thing you can actually try and remember quickly. Whenever I talk about the median, I'm talking about the middle value by position. So in other words, if I arrange them in that ascending order, I will say this is the middle of 10 or 11 data points. So that's the middle by position. It is also called the second quartile of data. There comes back the how a quartile relates to a median. But before I go back to the to how I relate those two, let me just talk about the first and the second. I mean, the third quartile. So a median of the lower half of data. So if I take, all right, if I said this is the median of my data, then this becomes where I started. Typically we say that's the minimum value and that is the maximum value. So this first quartile and second quartile, and third quartile, they basically saying if you were to cut half of what the median has done, the median has cut all the data into 2 equal halves. Now you're going to cut from the minimum to the median into 2 equal halves. Then we start talking the first quartile. All right? Now, if I jump over to that side, you'll see that that's another half, and I will call it the third quartile. Where is the second quartile? That matches exactly with what we called the median. So that becomes the second quartile. All right. So let's move on. Another way of looking at it is to say, okay, fine. The word median, you've heard it in Euclidean geometry maybe, where they say the median of the median of a triangle, basically bisects that's how it goes. Just reminding you a bit about the geometry. So you had a median, which is a line that basically goes and bisects the side that is opposite to that vertex up there. So now, one thing for sure is if you have that equal to that side equal to that one, then it means because they go to the same height, then you can say these two areas, if it's A and B, these two areas are therefore equal, because you'll remember the formula for a triangle is just half the base times your height h. So now if that base is the same as that base and the height is the same, so now that median, as in Euclidean geometry, is basically cutting the information into 2 equal halves. That's the kind of thinking we have with that. All right, let's move on. All right, I think we can take an ad break.
Let's do that, E.T. Okay, right, guys, so let's take an ad break. You can have a little stretch, go and run and get some water. I do know that there's some awesome mindsets that are tuning in. We've got Doctor's always on the page. He's always chatting, and he is watching the show as we speak. Kagiso says, wow, today is my favorite lesson in maths, which is really, really awesome. And a lot of mindsets are saying that stats are one of their favorite topics to talk about in maths. So stay tuned, and we'll be back right now.